Hi, in this video, I'm going to talk about kind of network evolution with taking a look at the future of networking. Uh, this is from a presentation I gave at Cisco Systems, not to Cisco employees, but actually to faculty and computer networking instructors in the Western area. So anyway, the future of networking, or I like to say the trends and predictions from the people who actually know what they're talking about. Okay, so we're going to look at the last 25 years of networking, trends, predictions, and some of the terminology. And how do we get there without driving ourselves crazy? So we will see some of the general trends. Won't be explaining the technologies and that, but just really looking at some of the general trends. So who are these experts that are talking about these trends? And where am I getting a lot of this information? Well, I go to places like Packet Pushers. I also want to mention Network Collective with Russ White, Chris Grundeman, and Ivan Popelniak. Jeff Doyle, Fred Baker, Giuseppe Cinque, and just reading and listening to a lot of podcasts, white papers from various companies, various people, etc. So first of all, let's take a look at the last 25 years of networking. George Allen said, forget the past, the future will give you plenty to worry about. So traditionally, so networking has traditionally been vendor-based solutions using proprietary hardware and proprietary software. Three-year change cycles are quite common, where every 3 years you're having to replace that equipment. Which means every 3 years you're getting bigger, more expensive devices, more complex devices with all the features and things that they've added to it, whether or not you use them or not. So you're getting everything, including the kitchen sink, and maybe not even using, maybe not using any of the new features, or you're typically not using all the features that's in these solutions. But you're paying for them, and you're also getting any issues that might be occurring with those features, perhaps. Okay, so we said vendor hardware, okay, plus the vendor operating system, plus whatever available protocols and applications that come with that model, with that operating system. And you're also paid for licensing and support. So this has been kind of the traditional model. We tend to put our trust in the vendor and the vendor solution. So we kind of buy a networking in a box. So where we just kind of plug it in, configure it, and use whatever they've given us. So I mentioned each cycle means more devices, more ports, more of everything, more cost. Okay, you know, our networks and how we're utilizing networks just grows and grows and grows. We're usually adding more ports, adding more features, needing more features, adding new technologies, etc. So service providers and large enterprises are the ones that are really feeling the effect of this, as their costs have just skyrocketed. And what's on these devices? Well, protocols, and more protocols. A lot of protocols, as you well know from studying CCNA and other courses. You're learning a lot of different technologies, a lot of different protocols, and actually trying to figure out how you make all of these things work together. Okay, and these are just some of the protocols that we talk about in CCNA and CCNP. I mean, this is just some of the ones I just thought off the top of my head. And there's many, many more. And then trying to get all these protocols to work together can be a challenge sometimes, because some of them don't work well together. Some step on each other. When you configure something in one area, might affect something else, or even within that protocol feature set. So understanding these protocols, configuring them is one thing, but understanding what's under the hood and how these protocols interoperate is something me and many others, of course, that teach this, try and get across to our students that it's very important that you understand what's going on, that what you expect that these protocols should do, how they function, how they operate, and how they interoperate with each other. So what does a network engineer do? Okay, the network engineer needs to understand these protocols, needs to understand how to implement them, how to design the networks properly, interoperate, monitor, configure, secure, and really make use of the network engineer's knowledge of how these operate and how to bring that to the network to have the network operate most effectively, most efficiently, and meeting the goals and demands, the requirements that the business requirements of why you have that network there to begin with, that network is actually meeting the business requirements for that organization. But what a network engineer tends to do is also do a lot of network device configuration, more configuration, and even more configuration. All these devices have to be typically configured individually. And when you start adding more and more devices, more and more features, and having to configure more and more, that's a lot of configuration. Followed by troubleshooting all those any misconfigurations. And that's a lot of what troubleshooting is right now, unfortunately, is due to a lot of misconfiguration. And that's because a lot of this is just so complex. So traditional based networking, we have high capital expenditure, mentioned every 3 year, having to replace equipment, 3-year cycles. Locked into proprietary hardware and software solutions offered by the vendor. High operating expenditures, so configuration of all these devices, support costs, licensing costs. Vendor network operating systems, so that comes with all the bugs, missing features, and unnecessary features. The network operating system kitchen sink, so you're getting and paying for not just what you need, but everything else that comes with that network operating system. And little or no customization. So if you want something different, you get either a different model, or you have to go to a different product, or go to a different vendor. I mean, it gets really complicated at times. I know, especially in the older iOSs, the way that we used to have to look for what feature set that you wanted, the protocols you wanted. Cisco used to have this network navigation, or this iOS navigation tool, to figure out what operating system would actually work for you. They've simplified that a great deal, but you're still getting the kitchen sink. And little or no programmability or automation. So basically, whatever that network operating system does for you, that's it. Can't customize it, can't program it, little or no automation, which offers little agility, little flexibility when it comes to deploying new applications, services, and infrastructure to meet not only your current customer needs, but any changing customer requirements. So the need for change has been customer driven. This hasn't been coming from the vendor. And that need is as is shown in various ways. Back in October 2012, a white paper was released by, you can see all the providers here that actually were asking for some kind of change. They can't just afford to operate like this anymore. It's just not cost effective, and it's not effective or efficient. So they're looking at changes at the fraction of the cost, faster speed to market. A lot of this, not only by looking at it from the change being called by these companies here, these organizations, but they're being driven by their own customers and having to get faster changes faster to market. They need to be more scalable. So there's a very good documentary, if you get a chance. It's TIA, which is part of EIA, TIA. They're the ones that do a lot of the layer one layer one, layer two type of standardizations. You might have seen them for cabling and rack mounts and things like that. But anyway, they actually have a very nice documentary series on networking, and part 6 talks about the network of the future. So I would recommend taking a look at that. Others, Gartner report. So Gartner is, if you're not familiar with them, the Gartner report is somebody that kind of looks at what's happening in the world of networks. They report on kind of trends, activities, and make certain predictions to look at cost factors and all sorts of things. But they predicted by 2020, only 30% of network operation teams will be using the command line interface as their primary interface. Not that the CLI is going to go away. Okay, that's down from 85% in 2016. So the idea of a network administrator, network engineer, and IT tech just being what we call a CLI slinger. I steal that from Russ White. But needs to go by the wayside. We need to utilize network engineering skills properly, not by just doing configurations. So some other predictions that they made is they talked about intent-based networking, SD-WAN, and we're seeing that already. White box, Brite box data center switches, we're seeing more of that. Deployment of direct internet access in the enterprise branches. So we're seeing that as well. So get ready for a lot of buzzwords. And I've got DevNet, DevOps, NetOps, and actually there's another one, DevNet Ops or Net DevOps is another one. But you're going to hear all these buzzwords: SDN, intent-based networking, SD-WAN, NFV, open switches, API, REST, Python, Puppet, Chef, Ansible, Docker, containers, controllers, a lot of stuff. And this is exciting. So let me pause for a second and just say this is an exciting time to be in the world of networking. So for those of you just beginning your networking careers, I'm envious of you. I mean, I still got a lot of years, I hope, left in me, but this is exciting. We're seeing the biggest change in networking, or we will see the biggest change in networking, whatever that might be. I'm not sure what's going to stick here and how it's all going to look, but probably in the next 5 years, we're going to be seeing the biggest change in networking that we've seen in the last 25 or 30 years. So things are going to change really big. So let's take a look at these trends, predictions, and some of the terminology. So the trends, they're around open hardware and open software, automation, programmability, intent-based networking. Okay, so, and none of this is going to happen overnight. So there's a big panic, especially around people my age. I've been doing this for a while. They think, oh my God, I got to have to learn all this, everything right now. And no, it's not going to happen overnight. And like I said, we're going to see what's going to stick. And I'll talk about, how we need to get there, or, as far as learning this, towards the end of this presentation. So keep calm, because it's just the beginning. Okay, so open hardware and open software. It's all about trying to reduce costs and have more changes. So whether it actually reduced costs is up for debate. But open hardware and open software, it's but basically it's a way to separate these entities. Okay, about having open switches. Hardware vendors, they use merchant silicon, off-the-shelf chips versus custom ASICs, application-specific integrated circuits. Choice of network operating systems. So being able to have maybe even open network operating systems. So choosing your own hardware, choosing what software you want to put on that hardware. And then the choice of protocols and apps that you want to be running on that network device. Okay, so an example might be using an HP branded Acton hardware, running open network Linux, using Quagga open source routing, and using HP for your support. So you can still get support for these devices. And then I won't even talk about, but there's even companies like Facebook and Google that actually make their own hardware, make their own software. And that's what they run in their own data centers. Protocols that they customize, that they create, even their own type of routing protocols. Okay, terminology. So we have open hardware and open software, open switches, white box switches, bare metal switches, merchant silicon. And then we have all these different vendors out there, Cumulus, Linux, AT&T, disaggregated network operating system, big switches, network, switchlight, and a lot of others. Okay, so there's a lot of terminology out there. And what's the difference between a white box switch, open switch, bare metal switch? Well, I won't go into the details here, but if you're really interested, Jeff Doyle, and those of you that are not familiar with Jeff Doyle, this guy is one of the legends, gurus out there. Many of us over the last 25, 30 years learned all about layer 3 and layer 3 routing, I should say, from Jeff Doyle. He wrote a classic 2-volume books of routing TCP/IP, Volume 1 and Volume 2, which was the Bible for understanding, not just configuring routing protocols, but understanding routing protocols. Okay, anyway, he wrote a very good blog on Brite, white, bare, metal. So the difference between all these different types of switches. There's also been a trend towards an open disaggregated operating system, separating the operating system from the hardware. AT&T has a white paper on that, as a matter of fact, that did a distributed network operating system white paper. Basically, it's all about faster introduction of technologies, a collaborative ecosystem. So they're saying this is not something that's going to be designed by AT&T, but the idea is that it's a collaborative effort. And one of the ideas one of the reasons for this is cost reduction through standard hardware and software technology components. So let's look at the other three here: automation, programmability, and intent-based networking, starting with automation. So automation is a methodology in which software automatically configures, provisions, manages, and tests network devices. Sounds pretty good, doesn't it? Okay, we're not quite there. This is an example here of how Ansible works, with using a inventory file and then a playbook, kind of a script, and then using either APIs or netconf. Again, these are all these terms and things that you probably may not be familiar with, and I don't expect that you would be yet. But we're all becoming more and more familiar with them. But it's the Ansible control host will actually use, let's say, an API, application programmable interface, to interact with a network device and actually do the configuration automatically. The idea is that it improves efficiency and reduces that human error. Remember all that misconfiguration and operating expenses. Okay, and again, we're trying to push out configurations, you know, in an automated format. How do we push out the what we want configuration-wise, not just to 1 or 2 devices, but possibly dozens, hundreds, even thousands of devices all at the same time? What if you're trying to implement some new QoS strategy, or adding some new security or voice over IP feature? Okay, so a lot of this begins to lead into something called intent-based networking. So intent-based networking is, and this is really where all of this is kind of, this is almost at the core. If I was going to do another slide, I might do IBN, intent-based networking at the core, and everything coming from that. The idea of intent-based networking is it's a network that has the intelligence and automation necessary to set and modify its configuration to meet an organization's business needs. Actually, before I go there, let me kind of just mention how we tend to build networks today. And I don't think I have a slide on this. But the way we tend to build networks today is, and let me actually use the whiteboard here. Okay, the way that we build networks today is we have business objectives. Okay, so I'll just put the BUS here for business. So this is our business objectives. Okay, so our business requirements might be another word to use on what we need the network to do. Okay, so the network's not just there to push a bunch of packets around the network and that, but it actually, you know, in business organizations, the network has to meet the requirements of the business. That might be quality of service, security, being able, allowing access to users for content and distributed content, and being able to monitor. You know, a lot of businesses, their business is based on the access to the network. Think about any of this, whether you're using Netflix or doing online banking or whatever it might be, or even at a hospital. You know, that is, you know, although the customer isn't using the network directly, but the people that work at the hospital, the doctors, nurses, staff, etc., you know, that's mission critical applications. Okay, so what we tend to do is that the network needs to needs to meet these business objectives, these business requirements. So what we tend to do, I might have the slide on this, and if I do, well, we'll see it again anyway. So what we tend to do is configure the individual devices in the network. Okay, so different, you know, individually. Okay, with a lot of those, all those protocols we looked at, with all these complex protocols. Yeah, and what we're doing is we're actually using technical configuration commands to implement business objectives. So we're somehow having to convert these business objectives into some kind of technical script, let's say, technical specifications, and then apply those to some kind of network design that we've come up with and apply them to the network, and then just hope that what we did here in our network actually meets our business requirements. And so what intent-based networking does is says, let's find a way to take these business requirements and through some kind of software, and I hate using the term SDN here because it's kind of an overused software term, and it means so many different things to so many different people nowadays, but some kind of software interface, then be able to say, take these business requirements and through software, be able to have that then interact with the network to meet these business requirements, instead of us trying to just do these through some kind of technical specifications. Okay, so let's continue with this here. So traditional base networks, okay, the devices have data planes, control planes, and management planes. So a lot of the configuration happens at the control plane. Okay, as you can see here, this is where we do our routing, we have our topology tables, we have our ARP caches, all kinds of things are all happening in the control plane. Okay, that information is passed down to the data plane and where packets are actually forwarded. Okay, so what does a network technician, network engineer do? A lot of configuration of each device separately, each device's control plane. Well, what software-defined networking does, SDN, the control plane in the first generation of SDN is centralized and separated from the data plane. Okay, so looking at this, we take the control plane out of the individual devices. We put them in some sort of individual SDN controller. Now what the network engineer does is configure the SDN controller with the intent of what we want that network to be able to do. And then that information is then passed down, programmed from the control plane in the SDN controller to the individual devices. Okay. So some of the terminology that you might see around this is things like open switches. Some of the products that are out there already, open switches, Linux Foundation, Open Daylight, using OpenFlow to send the data from the SDN controller down to the devices. The network engineer can either interact with the SDN controller directly or through some kind of applications. We call those northbound interfaces, and using things like REST APIs. So this is beyond what we're going to talk about here, but these are some of the things that you'll start becoming familiar with. And you'll be hearing terms like API, RESTful APIs, Python, Postman, JSON, XML, northbound interfaces, southbound interfaces. So as this stuff begins to manifest more and more, begin to see what kind of takes hold and what is almost the best way of doing these things. Again, we're at the very beginning of a lot of this. Okay, but we got to move away from individual configurations. So what does Cisco have to say about all this? Well, at Cisco Live, that's the big Cisco networking conference where we're talking about like 35,000 people are there. Chuck Robbins, who's the CEO of Cisco, his keynote address was all about intent-based networking. And Cisco's been dabbling in this for a while with things called ACI, Application-Centric Infrastructure, APIC and APIC-EM, Application Policy Infrastructure Controller, and they call it the network intuitive. So again, look at this. I mean, they're talking about introducing an entirely new era of networking. And again, this isn't Cisco trying to sell more stuff. If anything, this is a different business model for Cisco and all these other vendors. Let's think about it, right? Cisco and all these vendors have been making their money for a long time, not based on a model like this at all. This is almost 180 from their model of selling us hardware, proprietary hardware with proprietary software, with their applications, with support and licensing, and then having to buy newer, more expensive, and more devices every 3 years or so. Okay, now we're talking about a different way of doing this, perhaps even more open architecture in a way, open software, customization. Okay. So a lot of terminology here, okay, in automation and intent-based networking. Okay, so don't let all this stuff throw you right now, okay? We'll talk about how you can start to become more familiar with it. And personally, for those of you listening to this talk from one of my Cabrillo classes, we're going to be adding more and more of this to our own curriculum, and maybe even starting some new curriculum that's looking at this. Okay, programmability. Let's look at the last part of this. It means a lot of different things to different people. It can mean automating repetitive tasks. It can mean customizing functions. It can mean creating our own customized data and messaging protocols. It can mean data collection and programmability through APIs, application programmable interfaces. And right now, Python is the language of choice for networking devices. So if we kind of look at this, how are we going to be interacting with the devices? Okay, and it really depends on the device and the operating system, and also what the network engineer wants to do or how to do it. Could be writing Python code to interact with the device directly. Could be writing Python code that uses RESTful APIs to automate the device or configure the device. Could be using Python code and RESTful APIs to talk to the SDN controller that will actually control the device. Okay, so RESTful API. This is an application program interface API that uses HTTP requests to get, put, post, and delete data. I mean, you can use these even within web browsers. I mean, here's Google Maps, maps googleapis.com, and /maps/API/geocode/JSON !address, and put in your own address. Okay, this is an address where I used to live, and it will go out to, you're making a RESTful API call to one of Google's servers, and it's coming back and providing all this information to you in what's known as a JSON format. Okay? And then you can use Python to actually take this JSON information and format it different ways, or use it in different ways, even use it for other applications. Okay. So Python plus API equals information. Okay, so here we got Python doing an HTTP RESTful API call to get information. Okay, so you'll learn more about JSON and all this. Look up on YouTube, Wendell Odom, who's been around for a long time, talks about network programmability. So if you Google network programmability explained with Wendell Odom, he's actually at Cisco Live talking about this. Chris Grundeman, who's a network engineer that's been around a long time, works with, large service provider, also does talks for NANOG, North American Network Operators Group, and even in, here's the New York Network Operators Group. He's given a talk, ISOC and others. But anyway, he did a nice presentation on, will I be replaced by a script? And so let's talk about this a little bit more. My friend Giuseppe Cinque at Cisco Systems did a really nice slide here. He talks about the network you say the network used to be a lot of hardware. Well, the network is now software. So let's take a look at this. Let's look at connectivity, programmability, and security. So what we're talking about, the network is software, is everything now becomes connected. Everything becomes software-based, accessing it via software. Python, programmability, API calls, getting the information we need, pushing information to devices that we want, being able to customize it. And everything generates data. So being able to program that device, getting data from it, we can push data out to it, and everything can be automated, and everything needs to be secured. Okay, so about the future of networking. So there's, as Giuseppe says, there's an apparent contradiction. So these next several slides are actually from Giuseppe Cinque. It says, you know, the networking is going to be much simpler. A networker will need much more skills. So that sounds like a contradiction, doesn't it? Okay, well, I like this. He says, when the machine takes care of the repetitive, error-prone tasks, all that configuration, network engineers shouldn't be spending the majority of the time doing configuration, because you want to have more time for creativity. So I like this. You know, take away the vacuuming and being able to do more creative type of work. So here's an analogy from music that actually Giuseppe does. So typically in music, you start off with, you know, music theory and how to play notes on an instrument. Okay. Then, so we start here, and then we master that instrument. Okay, the technique for that instrument. And then we know everything and be able to address any situation with that instrument. We've mastered that instrument, right? Okay. And then we can maybe take that knowledge and expand it to a few other instruments. Okay. So it's like learning routing and routers and stuff. You master it, you start expanding it to other devices like firewalls and ASAs and multi-layer switches, that sort of thing. Okay, so what do we end up with? Well, this is what we end up with. Okay, so this is what we have. Okay, but that's not what we want. This is what we want. We don't want somebody playing a bunch of individual instruments. We don't want somebody just doing configurations on a bunch of different devices. We want somebody that orchestrates the network, that is in control of the network, not spending their time just configuring and troubleshooting a bunch of individual devices. Okay, I added this one. So this is actually me. I like the clown's face on here. It's my brother, Frank. All right. So how do we get there without going crazy? This last slide, just an infrastructure developer. Okay, how do we get there without going crazy? Okay, journey of 1,000 miles begins with a single step. So get the facts, okay? So we start looking at a lot of different things like packet pushers, network collective, I want to mention. Listening to a variety of guests and opinions. I like a lot of these, the network collective and packet pushers, people like, that's hosted by people like Russ White and others. Drew Connery does a lot of the shows, but you hear from the top people. They're unbiased, they're realistic, sometimes a little cynical because, you know, that's kind of goes with the territory sometimes. But they can tell you how it really is. So that's a little bit too cynical because, you know, but it's interesting listening to them over the years. They know we need to change. Sometimes change is a little hard. So how do we get there? Okay, learn Python. This is actually one of my favorite Python sites. It's a YouTube site, Max Goodridge, and he talks about learning Python. He does some great videos from the very basics of Python. He will walk you through it step by step. Okay, but then he starts to get into even more stuff. So start understanding JSON, and then understanding JSON with AP and Python. He does a great job of just walking you through learning more and more and more. So this young person, very impressed by his videos. I've watched many of these videos, many of the ones that you see right here. Okay, watch TV. So there's a lot of stuff out there on YouTube and elsewhere. Um, you know, start, I, you know, uh, uh, subscribing to different channels. You know, people like Kevin Wallace and David Bombay and others. Listen to different podcasts. Definitely look at Network Collective. Look at Packet Pushers. And this isn't something you can just all of at once sit down and figure all this stuff out. Just start listening to it. Keep an eye on some of this stuff. And little by little, you'll see these trends happening. You're very fortunate. You're right at the beginning of all this. Okay. Okay. And play. So I'm going to be getting my students probably in the next few months. We're going to be doing more of this. Trying to get some Cabrillo students who are interested in this, going to developercisco.com and their DevNet site. So they have a lot of free tools where we can get hands-on. Matter of fact, the Cisco Networking Academy has their own path within DevNet. And we actually I was fortunate to be part of writing a couple of courses to help the Cisco Networking Academy understand. I wrote something on learning using APIs and JSON and that sort of thing. So we'll probably be looking at that soon enough too in another video. This is just, again, the DevNet Center. They have a lot of different paths and stuff. So there's a lot of help out there, but it can be incredibly overwhelming. Okay, and so don't feel overwhelmed. Don't feel intimidated by all of this, okay? Just we're at the very beginning of all this. So, you know, keep an eye out for more stuff that I'm going to be telling you about for those of you in my classes, and also wanting to do more outside of the classroom to begin to really work on this. So most of all, just don't panic. We're going to see what sticks, what doesn't, and just take our time and look at this together.